All right, we are into our first, I guess, official module of the course, done with the review, and we're now into the meat of the course. And there still is, though, some review to be done. So we're going to be looking at the basics of graphing here and kind of the basics of inputting information into a function and getting information out. Now you can already see that I've already labeled this horizontal axis or kind of boulder horizontal line as x, and this y boulder axis or line as y. And so we have an x-axis, a y-axis. We've now made what we call a coordinate plane. And so the first question is, how do we graph points on a plane? And what you need to know is that a point is an x comma y. Now, what you also need to know, which I'm going to leave just said out loud and up for you to kind of review and practice because it's a little still review information, is that the x-axis, as you move right on it, you move positive. And as you move left, you move negative. As you move up, you go positive on the y-axis. And as you move down, you move negative. Makes sense up and down, positive, negative. But for horizontal, it might just be a little bit of memorizing that right is positive and left is negative. Now, what does that then do for us, or what are we saying about XY points, this axis, and these examples here? Well, what we're saying is, on this example 1a, we're saying I want to graph the point 2, y, or in other words, positive 2 on the x-axis, and then positive 5 on the y-axis. Well, what does that look like, and where do we start? Another good question. Well, we always start where these two axes meet. Now, this point is technically, if you want to write this here, it's referred to as the origin, which makes sense because it's where we start from, original. And that point would be the point 0, 0. In other words, we have not moved left or right. We have not moved up or down. We are directly where the two horizontal and vertical axes connect. So we know we will start on the origin on all of these examples. In other words, like even though there's A, B, C, and D, we're saying do this, then reset your brain and do this, then reset your brain and do this, reset your brain and do this. So let's go through these examples, and you'll see that these correspond to kind of the early first few examples in your homework for 1.1. So for 2, 5, we're saying I want to go right 2, positive 2 on the x-axis. So from the origin, I'll move right 1, 2. And notice I'm holding my pencil here, and then I'll move up 5 or positive 5 on the y-axis. Up 1, 2, 3, 4, 5. And so here I am, and I'll even label this point A to say that that's where point A is graphed. So from the origin, I went right 2, and then from there, notice I'm holding my pencil down, again, 1, 2, 3, 4, 5, after my initial move. With that being said, hopefully the next few are pretty straightforward, but here we go. We'll move left 2, left 1, 2 on the x-axis because the first one was negative 2. And then 3, so up 3, 1, 2, 3. That puts point B, or example B, or whatever you want to call it, right there. So left 2, then up 3. Up next, we have example C. Now that's the point 0, 4. Don't overthink it. Just think, again, how do I move left and right? And then from there, how do I move up and down? So I'm here at the origin. So how do I move left and right? Well, I move 0 left and right. I don't move anywhere. And then I move negative 4 or down 4. So down 1, 2, 3, 4. And this is point C. Now, finally, this one is the ugly one. There's 3 over 2, negative 7 over 2. And really, there's some extra stuff to be said about your homework and how you can plug stuff in, and maybe we'll have an extra supplementary video for that. But really, all we need to do here is just notice that this axis actually is pretty wide. I know it looks small, but, well, here, I can zoom in on the camera. But if I want to move 3 over 2 and negative 7 over 2, let's write the equivalent version of that as a decimal. That would be 1.5. Again, you're allowed to use your calculator there. Feel free to calculate that. And then negative 3.5 is what I'm getting when I convert that to decimals. Okay, well then let's look at that example now that I've written it in decimal and I can still see it on the screen. Let's see what that looks like on the graph. So from my origin, I'm going to move right, because it's positive, 1.5, and now I'm still holding my pencil there, and then I'll move down 1, 2, 3.5. That puts me right here for point D. All right, so I moved right 1.5 units and down 3.5 units, which put me not on the grid, so to speak. I mean, there is a grid here. You can always draw more what we call minor grid lines, but I've still plotted that point correctly. It's just halfway between the tick marks, as we would call them, on the axis provided. So just be aware that there are times where you might be asked to graph half points or third points, and usually your homework tool will actually give you a window to do that. And let's see if I can bring that up for you. All right, so for this example, you can see that they wanted me to graph the point -7.5, positive 5/2. And so if I could pull that up, now I'm going to try to zoom in. The zoom feature is a little iffy on this, but you can see that even so, this axis, careful, watch, it is already counting by halves. So let's see here, just so I could see it. -7/2 would be -3.5. Sorry, I need to make sure I could see the original problem. -7/2 would be -1, 2, 3.5. That's where I'm at so far, but I'm not stopping there, because then I have to go up 5/2, which is up 1, 2.5. And so there I am at -3.5 and up at 2.5, and that's where I've landed, and I can save, check that, and there we go. Awesome. Now where that then takes us is graphing functions along a grid. Now you can see we have all the x coordinates provided for us in a table, and they want us to find the function values we get out of this function. So for the first few, we might try to work them out individually. So what this is saying is, I want to know what I get when I plug -3 into this whole thing. So let's work that out on the side here. Absolute value, -3 minus 2. And you can see I'm just substituting that value of -3 in place of x. That's all that's going on there. This says I want x to be -3. There's a function of x, which I'm then saying I want this x to be -3. It's inside absolute values. I'll deal with that in a minute. And then there's a -2 after the fact. So we're just what we call substituting. We haven't done any work yet. It should be a simple kind of find and replace if you think about it. This said x, this is -3. If that said x, then that says -3. And we're kind of skipping, so to speak, the f of x along the way, because we know ultimately we're just plugging x in, -3 in place of x wherever we saw it. All right, well, what happens here with this? Well, what is the absolute value of -3? If you don't know, the absolute value of -3 means how far are you away from 0, and -3 is still 3 away from 0, and then there's still a -2 after, and that simplifies to be 1. And so what I have now, we're going to have to go a little quick here, but what I have now is I have a point -3, left 3, comma 1, and there's a point on the graph. Now we can go a little more quickly, and I am going to go quickly, but if I plug in -2, and I'm going to start saying it out loud, -2 inside the absolute value becomes 2, and then 2 minus 2 is 0, and now I've got a point -2, comma 0. Let's graph that. -2, comma nothing up or down puts me right here. -2, comma 0. Let's go further. -1 plugged in. -1 plugged in becomes +1. +1 minus 2 is -1. Again, be careful of the operations. We're going a little quick here, but -1, -1, left 1, then down 1 puts me right there. Up next, let's plug in 0. 0 plugged in, well, the absolute value of 0 is still 0, and 0 minus 2 is -2, so I get -2. Now, so far, what you can see is as we've decreased in x, we've decreased in y, but just be careful, that trend doesn't always continue, and you'll learn later on in this course when that doesn't continue. But let's graph this point 0, -2. Now we've got the point 1 to plug in. Well, what's the absolute value of 1? Well, 1 is still 1 away from 0, and 1 minus 2 is negative 1. And so now we're not going in the negative direction. If you plot the point 1, negative 1, you end up right here. And I'll continue this, and you can just see that we end up with 0, 3, 1, and I've found a pattern here. And all I'm going to say early on in the course is right now you should not trust the pattern I found or how quickly I did it. You should, go through your chapter 1.1 exercises and plug these in one by one. It might be a little time consuming, but I will assure you by chapter, I think 2, 3, or 4, somewhere early in the first half of the course, you'll learn to recognize this absolute value as making this V shape. And you'll know all these other points and how, here's the key concept early on to kind of spoil it, that this graph must be negative 2 or down 2. And look where this special point is where the V forms. It's negative 2 from the origin. And I'll tell you just again, that's not by coincidence, but that is kind of preluding to what will happen later on. However, here's the giant point of this example. No matter what, if you can plug stuff in and carefully follow operations, I know we only did that fully for one example, but if you can do that fully, technically, you don't need to memorize shapes. However, as mathematicians, we realize we kind of need to if we're going to be able to go through stuff more quickly. Speaking of going more quickly, let's look at a few more examples of plugging stuff in just to make sure you're acquainted. Now, these don't necessarily equate to homework examples, but I wanted to kind of highlight some extra powers you'll see in your homework and just give you other questions to look at. So, I'm trying to refocus. Looks a little better. We'll go with it. So, we need to plug in 3 into this thing. We need to plug in 3 into this thing. Now let's see how that behaves, and let's carefully learn to follow what we again call our order of operations. Our order of operations, if you don't remember, is PEMDAS, where the P stands for parentheses. Now notice we don't have any here yet, asterisk. Exponents, we definitely see those. There's a power of 2, a power of 3. Multiplication and division, now here's the thing I want you to do. Underline those because they can be done in any order. And addition and subtraction, they can also be done in any order. Now the caveat to that is multiplication and division done in an order, addition and subtraction done in an order, and particularly when there's no other operations to do. So you still are prioritizing the order, but it's leave the addition and subtraction last, but they can be done in whatever order you see fit. Anywho, let's plug in and see what we get. So this says f of x is this function. And really, again, as a mathematician, that's all you need to say is f of x is this thing where x will get plugged in later. Now, if I want f of 3, here's where I'm going to start writing. Well, what did I do? I replaced x with 3, as I kind of said before. So maybe this will connect what we did earlier. Well, there's a negative 3 here. And because I'm substituting, and because I'm not going to be a lazy mathematician this early in the course, I'm going to do my substitution with parentheses. Similarly, I'm going to do my substitution with parentheses, and I've got my plus 5 at the end. So notice what I'm doing there is everywhere there was an x, so there was x squared, there was 2x. I've now replaced it with 3 squared and 2 times 3. And I've done that in parentheses to kind of call back to the PEMDAS, and that is what you should do when you substitute. Now let's work this out, and let's see what we have here. So there are parentheses in our problem, but what do we mean by parentheses? Well, we mean if there's algebra to do inside, then please do it. However, all I have here is a 3 and a 3, so the parentheses are simplified, so it's time to move on to E, exponents. What do my exponents do? Well, there was a negative 3 out front. Now 3 squared is 9. Then I've got a 2 times 3, but I'm going to hold off on that because that's multiplication. And I've got a 5, or a plus 5 at the end. Plus 5 at the end. All right, well, now I've done my exponents. Let's do my multiplication. My multiplications, there are two of them, and I can do both at the same time, and I should do them because m comes before a or s. So multiplication would be do the negative 3 times 9. They're written next to each other, so that's what we're supposed to do. Multiply them. And then I've got my 2 times 3, that's positive 6. I'm keeping the positive on that. And I've still got my plus 5. Now, after I work that out, what I get is, well, let's see here. I believe negative 16 is what negative 27 plus 6, because that would be negative 21. Negative 21 plus 5 is, yep, negative 16. So great, I got negative 16 for my answer. So all of that was just plugging in f of 3. And again, I hope this is extra practice to plug stuff in and see what you get. All right, let's keep going and do g of 3 a little more quickly. Now this one, by substituting as 3 cubed, oops, not equals, but then minus 12 times 3, and then plus 5. The plus 5s at the end, really, I'll tell you, that's copy and pasting laziness. It could be plus anything. Don't be afraid of that. It's more so plug in place of x what you had before. So 3 cubed is 27. Negative 12, well, at this point, sorry, I'm kind of skipping ahead here, but here's what I can tell you as a mathematician. Because I dealt with my only exponent, I'm now free to do the multiplications that I see. So negative 12 times 3 is negative 36. So I can handle that exponent as its own term and do my multiplication as its own term, and I can still deal with the plus 5 after. And so at this point, let's see what I get. That would be 32. Notice how I'm making the positive out of that just mentally in my head because I don't have a calculator right now. That's 32. That's negative 36. This must be negative 4. And so the way I'm doing that is really also to preface that A and S, addition and subtraction, are done in any order. So when I see a 27 and 5, I mentally just said, let's make that 32 in my head. 32 minus 36, that must be negative 4. And now I'm good to go. So there we go. The one thing you might need to do or spend a little time on is in your calculator figure out where is your cube button. So I'm gonna go ahead and say consult Google. Because there are so many different calculators out there. Please don't use your phone as a calculator for quizzes or exams because number one, you can't. But make sure you have a calculator that you know where the exponent button is and you know how to cube things easily. Okay. Last question we have to do in this first section is determining x and y intercepts via a graph. Now, this example, it looks pretty wacky because we haven't really seen curvy graphs in this course so far directly together. However, we can still figure out what an x-intercept and y-intercept is. Now, an x-intercept is simply where does a graph cross the x-axis, and so maybe I'll underline those like that. And maybe for the y-axis, we'll go ahead and make an extra solid dashed line. Now, please hear me on this. There are times in math where solid and dashed lines are used in different contexts. I'm just trying to say I'm going to label the x-axis and the y-axis with a horizontal and dashed line for sake of visual viewing here, just for this one example, but don't always label them with horizontal and dashed lines unless you're indicated a reason to. So this is just a visual aid, not a general practice. Anywho, with that warning, let's see what's going on here. I can see that on the x-axis, this red graph, although it's really curvy and it goes everywhere, on the x-axis, I see it crosses at negative 2. So guess what? One of my x-intercepts is negative 2. Another one of my x-intercepts is 1, because that's where it crosses the x-axis. Another one must be positive 2, and I've now just determined my x-intercepts, negative 2, 1, 2, because that's where my red graph, whatever that graph is, I don't know what the equation is, but I know it crosses at negative 2, 1, and 2. Similarly, the y-intercept, where does it cross the y-intercept? Well, it only crosses in one place, and it crosses at positive 4. And there's my y-intercept. So that gets us through 1.1, kind of the basics graphing, plugging in, and looking at x-intercepts and y-intercepts. Now, I can tell you later through the course, x-intercepts and y-intercepts will be very important, but hopefully that gives you a little preview. I'll see you in the next one.